All right, so welcome back. We're going to continue from where we stopped. Next, now let me remove that hashtag so to make this code active again. So look at that sphere. The sphere is very big. I don't want the sphere to be that big. What do you think I have to do? Reduce the radius. So the radius right now is about 1 or something like that. So I've got to reduce it by an order of magnitude. So position equals vector. Let me give it 0 0 0 0 0 0. That does nothing really. It just sets the position of the mass to 0 0 0. And then radius equals 0 0.2. So when I put the radius equals 0 0.2, what happens? Let's see. Oh, look at that. The mass got smaller and it's attached to that spring. What do you think? Let's predict the code. What do you think we have to do next? Of course, color equals color.red. So color equals color.red. I'm going to save it, run it. All right, this is looking great. Next, what do we want? We want it to move, right? We want it to move. It's not moving right now. We want it to do this. You can see it's moving here, right? So we need it to move as well. So what do? We define a loop. We write a while loop. So in Python, whenever, or in programming generally, whenever you want something to repeat, whenever you want to do animations, you do a while loop or an if loop. Okay, so how do we write a while loop? Now before I do that, let me define the time. So let's define the time, the simulation parameters. So the simulation parameters, t equals 0 0.00 seconds, and then dt, that's the time step, is equal to 0 0.01. Let's give that 0 0.01. I didn't put the point. Oh, that's a comma point. All right, now let's do the physics loop. Please don't you write while true. Do not hit enter and try to run it, because that would be an infinite loop. While true would give you an infinite loop. What should happen while true? So while true, we'll say rate is 100. The rate should be 100. So it should move at 100 frames per second. There's something I didn't define. I didn't define the initial position and the initial momentum. So let's define the initial conditions. So the initial conditions, mass.v, that's the velocity. Remember our notation. The velocity is equal to vector 0 0 0. That means the initial velocity is 0. The object starts at rest. So that's the initial velocity. Then we'll define the momentum. So what is the momentum? Momentum is equal to mass times velocity. So mass.p, p for momentum, equals m, that's the mass, times, this is how you do it times in Python. You just put a star, it's above the 8. So you do shift 8, mass.v. So that's the initial momentum. We've defined the initial momentum. So this will run at 100 frames per second. Next, let's calculate the current length and displacement. So I'll say S vector. Remember, S vector is the length from the start of the spring to where the mass is. So S vector is equal to mass.pos minus spring dot pos. Then we'll do the magnitude of the s vector. The magnitude of the s vector, s mag, is equal to mag. Mag function is in VPython is to calculate the magnitude of something. Mag s vector. And then next we'll calculate the displacement. That's the extension of the spring. Remember, Hooke's law is equal F is equal to KE. Our E extension here is displacement. So displacement equals S mag, or I wrote a 9, S mag, that's the magnitude of the S vector, minus the relaxed length of the spring, which is L. Next, we're going to calculate the force using Hooke's law. So the force on the spring, or the spring force, that would be equal to minus K, that's Hooke's law, times displacement times the norm of the s vector. So whenever you see norm, what does that mean? It means the unit vector. So you have to multiply the displacement by the unit vector, so that whenever the direction changes, you would also get the force to change. So next, we're going to update the momentum and position. Update momentum and position. So let's do that. We'll say mass.p equals mass.p plus F spring, that's the force on the spring, times the t. Update the momentum. Next, you update the position. Let's update the velocity as well. So mass.v equals mass.p over m. And then the position, mass.pos, update the position, equals mass.pos plus mass.p over m times the t. Like that. Let me space this out. Nothing happens, but let's learn to write clean code. And then finally, we'll update the spring's visual representation. So we'll say spring.axis equals mass.pos minus spring.pos, and then update the time. T equals t plus the t, or you could just say t plus equals the t. All right, so when I run this code, you should see this pendulum oscillate just the way this one is oscillating. Okay, so let's do it. Let's run the code. I hope we don't get any errors. Oh, there's an error. Unexpected token true at line 27. So at line 27, there's an error. While true. What do you think the mistake is? I wrote while loop with capital W, supposed to be small w, like that. You see the color changes, which means now I've written the correct code. Let's save that and run it. There's another error. Okay, let's see. Cannot set properties of undefined setting v at line 14. Okay, at line 14, I did not. Mass.v equals vector 0, 0, 0. Oh, okay. I think it's the, Python runs codes from top to bottom. I was not supposed to define these initial conditions after the constant. So I would remove that and put it down here. Okay, great. I think this should solve the problem. And let's see. All right, displacement is not defined. Oh my goodness, there's so many errors here. Displacement, but we've defined the displacement. Displacement equals S mag minus the length. Oh, I made a mistake. Please don't make this mistake. Displacement, I spelled displacement without an L. All right, so hopefully that fixes the problem and our code should run. Run it. I hope we don't get any. Oh, no errors. But the mass doesn't move. Why? Oh my goodness. Oh, okay. When I defined the mass, I put the position vector to be 0, right? That means I did not give the mass an initial displacement to the right. So let me give it an initial displacement to the right, because if you have a pendulum and you don't pull it to the right, it's not going to oscillate, right? So let's give it an initial displacement of 0.5 to the right. So it's just like pulling the mass to the right and then releasing it. So what do you think should happen? I'll save the code and I'll run it. Voila, look at that. Beautiful. You can see the pendulum starts to oscillate now. So there's a lot of things we can do to modify this code. We can change the rate. We can change the rate to 200, for example. And then what do you think would happen? It would oscillate faster and faster, right? Look at that. It oscillates faster and faster. So I want you to play with this. You've got an exercise. Include damping forces. And then write some Python code to plot the energy. So if you cannot do that, I'll do it in my next video and I'll show you how it's done. Thank you very much for watching. I'll see you in the next one.